Welcome back to Walking on a Cloud with Marco. Today I'm gonna expand on what I was talking in my previous video, and that's denial of service attacks. As I started already in my previous video, I sort of explained how denial of service attacks, distributed denial of service attacks work. Now, of course, when we talk about denial of service, we're typically now talking about distributed denial of service because it is so difficult to bring down an application just from one machine. So any denial of service is going to be done by a sophisticated attacker that has multiple different bots. Now, of course, I mean, if somebody breaches your environment internally, that's still possibly a denial of service, but we're not going to cover internal attacks. All of this stems from a report coming out of AWS Shield where they said they had an attack that was 2.3 terabits per second at the peak, which means that if these were 1 megabit devices, there must have been 2.3 million of them to be able to attack at this level, which is quite honestly a really, really big number. If nothing else, I've never seen something like that. There were previous terabit attacks that brought down services, and I'm gonna post some links in the description if you're interested in reading up on the previous attacks. Now, this one didn't really register as far as the users are concerned. It did register on AWS's Shield service, but users did not see any effect. However, that does not mean that you're protected from distributed denial of service attacks, right? So we're going to look at all the layers that you need to put in place to protect yourself from DDoS attacks as much as possible. Now, first thing, of course, are your network security tools. So in AWS, we talk about security groups. These are your personal firewalls for your instances. They run on the Elastic Network Interface and protect your instance from external traffic. They're just port-based firewalls. They're stateful, so you open something coming in, you can expect the response coming out will go out of the box. They only have allow rules, no deny rules, so everything is denied implicitly. And of course, if you open something up, then traffic goes both ways. Now, the second layer is, of course, the network access control lists. In your VPC, you can create network access control lists and allow traffic, again, port-based traffic with some destination sources, and you open up ports, but it is stateless because, of course, it protects the whole network, and a network might be a C-class range, and you know that means there's 254 devices. Might be a B-class range, up to 60,000 devices. Anyway, because of the sheer number of instances, it's a stateless service. It's just a set of numbered rules that it will either allow or deny, and when it hits a rule, it will allow the traffic. But of course, because it's stateless, you also need to ensure return traffic comes out. Read up on those. This is also very useful for advanced security, for the advanced security certification. So if you're going to go past the advanced security certification, not advanced security, advanced networking certification, and the security certification, both of these have, you will benefit from this, definitely. Now, of course, I forgot the underlying component. The first major line of defense is making your networks private, only exposing services that you actually need to expose to the internet, right? So what you want to do is you want to run as much as possible in private networks. If you do have public services, put a service in front, like a load balancer or an API gateway, or other options, like just put CloudFront in front of it. Well, actually, CloudFront won't work. Anyway, put a service in front of it. Put the API gateway or your own solution. right? You can use your own solution, whatever your own solution is, your own load balancer tier, your own web application firewall tier, whatever you like, right? You can put the web application firewall also in front. We'll talk about that a little bit later. But one thing we can't forget is the security inside of the operating system. So inside of the operating system, you still have the ability to turn on firewalls. Now, if your firewalls are more intelligent than security groups, which are just port-based firewalls, if you have a firewall that can actually analyze patterns on those ports and detect traffic, something like next generation firewalls or modern web application firewalls, then yes, put those into your application. At least the least thing you should be doing is putting in some IPS, IDS devices, well, software inside of your operating system to ensure that if anything unusual does happen, you can get notified. Or track your application logs very, very strictly. Put a Lambda function on top of your application logs and, of course, analyze those. And I'm not saying or, I should be saying and, right? Make sure you export your logs, make sure you can reach them with an analytics service, and then analyze what's happening in those logs. Continuous analytics of logs is something that is forgotten a lot of times in security. It's like, yep, we're logging. Are you doing anything with those logs? You know, other than the 3-month review or whatever. No. And that's a lot of times a place where you can stop the attacker with the logs, right? You can see, oh, something weird's going on. Somebody's downloading a ton of files from an S3 bucket. Stop it immediately, boom, right? Stop it and then ask questions later. That's the idea. You gotta stop a breach. You don't ask questions. Oh, who's downloading this? You just stop it and then you work with whatever you got. Alright, so once you got a service in front, like let's say we put a load balancer in front of some EC2 instances, we put a network security, network access control list, we put a security group in front, we've got an IPS, IDS service, and a basic firewall also inside of the operating system, just you know, just for the sake of it, just to make sure that that instance isn't exposed even internally in the security group. Internally beyond the security group, let's say that in some form, you know, somebody messes up the security group, an admin makes a correction on the security groups in general, runs the CloudFormation template, it affects all security groups, and suddenly another port is open that shouldn't be, right? Then it's your instance firewall that will stop that. So you got a double layer of defense, right? We always think about, oh, we need to protect from, you know, network threats and somebody trying to break in. No, it's like somebody making a mistake that's gonna, most of the times, it's somebody making a mistake that actually leads to a breach. It's not even hackers trying to get in. Yeah, I mean, they're trying to get in, but if there's no mistake in the environment, they're not going to get in. They get in because somebody didn't patch, because somebody left something open, somebody didn't encrypt it, somebody left an encryption key somewhere. This is like 90%, when you go down to it, 90% of the issues that happen is just basic human error that leads to those problems. So what you want to do is you want to have layers of defense to prevent from human error. That's why we have availability zones in AWS, right? An availability zone has a network that is completely separate from another availability zone. So if you make that mistake, if you do mess something up, you're not affecting all availability zones, right? That's like logic. Just separation, complete separation, right? Okay, so we got our instance firewall, we got our security group, we got our network access control list, we got our load balancer in front. Now what we can do is we can integrate a web application firewall into the load balancer. The old way of doing things was a WAF sandwich, so where you would put one load balancer in front, which is public facing, one load balancer internally, and then a layer of web application firewalls to just perform filtering on layer 7, right? And when you understand your layer 7 packets, you can filter much more than just based on port, based on port 80 or port 443 or whatever. And an application layer firewall can protect you from the OWASP top 10. And I'm gonna put a link to OWASP. So it's the Open Security for Web Applications, something like that. It's a group that actually is completely autonomous, that has come up with some rules that will prevent, stupid things from happening. The top 10 is basically a top 10 rules of what you shouldn't be allowing on your web server. So OS top 10 is definitely a set of rules that you need to enable, and that can only be enabled through a web application firewall, a layer 7 firewall that understands the web protocol, the HTTP or HTTPS protocol. Now the modern way to do things is to actually implement web application firewall at the edge location. So what you do is, in front of that load balancer, you drop a CloudFront environment to cache any static content. That's number one. Content delivery is definitely going to accelerate your application. And number two, you can create an access control list for your web application firewall on top of the CloudFront service, right? So essentially, you're now blocking all attempts at things like any kind of exploits, like any kind of injection attacks, any kind of strings that you don't want to have, any kind of IP address ranges you don't want to accept traffic from, any kind of what else can you block? But it's a ton of different things, right? Request forgery attacks, right? You can put that, enable that, and just protect from that directly at the CloudFront at the edge location, which means you've got 200 locations in the world where you're just gonna block the traffic. You're at the cone of the traffic, right? At the entry point. And if you can think of it, the way we used to have an entry point was a big old pipe to our servers, and our servers would then take the traffic through that pipe, right? Now, when we have CloudFront, we have many little small pipes. It's like a hedgehog, right? It's like many little spikes across the globe. It's like one of those balls that kids have with the little spikes at the end of them, right? So that's what it's like. And now you're protecting your application at each and every point. Again, when you're using CloudFront, you automatically get Shield. Shield standard comes with CloudFront, comes with the API gateway, comes with the does it come with load balancer? Possibly also with the application load balancer. I'm not 100% sure on that one. Anyway, Shield standard protects you from all layer 3 and layer 4 attacks, all kinds of layer 3 and layer 4 attacks. AWS just cuts them off. If it's a malformed packet on layer 3 or layer 4, if it's a SYN flood that they're trying to do, if it's a UDP reflection attack, all of those are just sliced off the network. So you don't even have any of those. Now, if you want, you can get Shield Advanced, which is an advanced protection service, which gives you DDoS protection at layer 7. And of course, we'll also have a 24/7 response team that can help you mitigate your DDoS attacks. I think it's about $3,000 a month. If your application is making a ton of money and you want it to be up and you can't lose one user, or you don't want to degrade the user experience, then Shield Advanced is an option for you. At the end of the day, what you need to have is you need to also be able to scale out and absorb the attack. So anything that does come through the Shield, through the WAF, through the load balancer, through the security groups, through the network access control list, through your personal firewall, through whatever security devices you've put into the operating system, security software you put into the operating system, if there's a packet that comes through, and like I said in my previous video, it could be a valid request for, an image, a large image, or your logo, or something that will try to put load on your servers. In that case, when it's valid requests, you still need to be able to absorb. So then auto scaling is your only option, right? At that point, you scale out to as much as you need to absorb the attack and still be able to serve all requests from your users. That's your sort of last layer of defense. Now, if you have Shield Advanced, any kind of scaling to absorb the attack will not be priced. So there will be no price. They will not charge you for any scaling to absorb the attack. You will just be charged at the regular rate that your application runs. So as soon as, for example, a DDoS attack is identified, they will preemptively scale out your application, and you will not pay anything for those minutes, seconds, hours of whatever you're scaling. Whereas if you're doing it on your own, you're going to be scaling it. And there's a bunch of different white papers on that. One's really interesting from I don't remember the name of the company. It's a medical company. They had a big conference in LA, and they had 15,000 attendees, and they wanted to show this new feature on their public website live during the conference, right? And the morning of the conference, they started seeing a DDoS attack, and everybody's going crazy, like, oh my god, we have 15,000 people that we're going to be, and these are their customers, their tightest customers. We're going to be showing them these features, and now they're not going to work. So essentially what they did is they followed the rules. They cut off some IP addresses that they saw the attack was coming from. They put in place they actually ad hoc put in place a web application firewall. They switched the traffic through a CloudFront distribution, just to ensure that anything that would, any static requests would go just to the cache and not to their application servers, and they scaled out a bit. The attack lasted for over 36 hours, and then the attacker was just like, well, we can't beat them, right? They had zero downtime. Their application was performing marginally worse than it would be without the attack. We're talking about maybe 10 milliseconds worse in responses than if they didn't have the attack. They saw over 600 megabits of traffic headed their way at the peak of the attack, and they also spent about $1,500 to absorb the attack during the 36 hours that they were under attack. So that is not a lot of money. If you think about, this is a product that they were showing to 15,000 attendees at that conference. That conference, they were building up to that conference for 6 months, both the application and the preparation and everything. An attendee paid around $1,000 to be at that conference, right? So 15,000 people times $1,000, it's $1.5 million, and $1,500 to make sure that application works. Drop in the bucket. Drop in a bucket, essentially, right? We're talking about really like low cost. Everybody who says, oh, AWS is so expensive, yeah, because you're using it wrong. You can use AWS wrong, you can use Google Cloud wrong, you can use Microsoft Azure wrong, you can use all kinds of cloud services incorrectly, and when you do use them incorrectly, it's going to cost you a lot of money. Now, when I say use them incorrectly, what do I mean by using them incorrectly? What's an incorrect usage? Well, first thing, you've got long-running resources, you got no reservations, right? No reserved resources on long-running compute. That's gonna cost you a lot of money, right? You can save, I'll guarantee you 35% of savings by, you let me into your environment, I'll see what is long running, and I'll guarantee you 35% saving on that, on just any long running resource. And then you've got things like, for example, oh, but we have this containerization instance that needs to run so that if any ephemeral containers spin up and shut down, but it's not doing anything. Look, you have services that perform that. You don't need to run a server that's waiting for requests. You don't need to run a backend server that waits for requests from the front end, right? Deposit the message into a queue from the front end, let the queue be your trigger for scaling, create the instance, process the message, shut down the instance. Oh, we like Jenkins, and we have a cluster of Jenkins servers. There's 15 nodes, and these 15 nodes are killing our budget. What are you doing running Jenkins nodes 24/7? Like, are you doing builds continuously? Well, no, the system has to be ready for builds. No, the system doesn't have to be. Well, yeah, I mean, you got the master that needs to be ready, but all the workers, you can shut them down until there's a task, and then automate the spin up. Have Jenkins run a script that spins them up, registers them, and then run the build process on them. Well, but that's complicated. Yeah, that's complicated. Yeah, you're using the cloud incorrectly. When you use cloud correctly, you're using services where you reserve for long term, and anything that's not long term, anything that's ad hoc, you start up, do the work, shut down, terminate. I can't terminate my instance because I'm gonna lose all the data. No, your data shouldn't be sitting on the instance. Your instance should be stateless. Your container should be stateless. What are you doing? What are you doing storing data on your instance? Right? Like these are real questions, real world scenarios where people do things wrong because they're used to doing things that way. Why are we used to doing things that way? Well, maybe that's a topic for another video, because I'm segueing out of the DDoS into cost optimization. We'll save this one for the next video. But in any case, I'm gonna say thank you very much for watching. Please, if you're interested in seeing more of this stuff, if you want to validate my effort for building these videos and recording all this stuff, please comment, please subscribe, please like my videos. That's the only thing I ask of you. It doesn't cost you anything except your time. If you've got the subscription on, you really, I mean, what does it cost you to subscribe? And it'll help me reach the goal of 1,000 users when I'll be able to do live streams off of my mobile devices, which I am not allowed to do until I reach 1,000 subscribers. So I would really appreciate if you help me get to that goal so that we can make this stuff much more interesting. All right, I'm gonna sign off. Thank you very much for watching, and I will see you in my next session and my next episode of Walking on the Cloud with Marco. Bye.